Welcome to lesson number 2. We're going to be looking at relationships between two quantities today. And we're going to be starting on page 238. So this is on page 238. And this illustration shows us the equation y equals 3x minus 5. So this is an example to illustrate the difference between the independent variable and the dependent variable. So first of all, our dependent variable in y equals mx plus b, so y equals mx plus b, is the value that will represent the outputs if we were to input something for x. So if we were to input, let's say 1 for x, our output would result in -2. Now values of our dependent variable of y are represented by the second coordinate of an ordered pair and are on the vertical axis. So if I have a coordinate x, y, this is my dependent variable. The independent variable x, this is the input value or the input variable. So if I change my input, that's going to change the output. And the value of the independent variable, this is going to be located as the first value in our coordinate and is usually on the horizontal axis. In class example number 2, I have diagrams that show relations expressed in 3 different ways. And I want to state the independent variables, I want to state the dependent variables, I want to list the inputs, and I want to list the outputs for each of them. So first of all, I'm going to look at A right here. So with A, I want to state the independent variable first. So the independent variable of A is going to be P. So these values here are my independent variables. 2, I want to state the dependent variables. My dependent variables are going to be the value on Q. Part 3 wants me to list the inputs. The values I'm going to be inputting, or that are taking my independent variable places, are 5, 8, and 11. So 5, 8, and 11. And whatever my inputs are going to result in certain outputs. And that's 4 here, and that's 10 and 16. With example B here, I have these are my independent variables, would be V. My dependent variable is A. My inputs would be related to my independent variable, so that would be 4, 10, and 25. And then my outputs are 15, 12, and 15. So first of all, I have my independent and dependent variable. So I would be B, or 2, sorry, is C. And then for my my inputs, those are my X values, or my B values here, so 3, 4, 5, 6. And then my outputs are my Y values 7, 11, 15, 19. Next, I have class example 3. Relations are expressed in different ways below. In each case, you want to state the independent variable. So the independent variable here is going to be R. So I would be R, because the independent variable is related to my input. So if I input something for R, that's going to result in an output, or that's also my dependent variable, which is C. Over here, the independent variable here is going to be T, or time, and H will be my dependent variable. That's related to my y-axis. Now, the amount of sap, or S, obtained from a maple tree is dependent on the time a container is left attached to the maple tree. So what we want to do is, again, label which one of those is the independent and which ones are the dependent variables. So time is going to be independent of how much sap is flowing, and so that means, or how much sap is collected, and so that means that sap would be the dependent variable. So however much time we input is going to be directly related to the amount of sap that we obtain. In example number 4, we're looking at this relation, and this relation is described by the equation y is equal to 2x minus 5. we want to complete the first rows of the following table of values which show some of the possible input values. So if I'm plugging this into y is equal to 2x minus 5, my input values are here, and so as I input -2 for x, 2 times -2 is -4, subtract 5 would result in -9, so -9. Next, 2 times -1 minus 5, 2 times -1 is -2 minus 5 is -7. Now, if I were to continue going, and actually let's see what we're supposed to do as we continue reading, but before we go any further, let's list our ordered pairs. Now what we want to do is plot these ordered pairs onto our graph below. And so, first of all, I was at -2 and -9. That's my first plot. -1 and -7. I'm at 0 and -5, 1 and -3, and 2 and -1. Now we want to connect the points on the grid and extend the line in both directions. So I highly recommend a ruler for these graphs. Now we want to use the graph to determine the value when x is equal to 6. So when x equals 6 right here, we should be at 5, 6, 7. 6 and 7, and that would be my next points. And we also want to know, use the equation to determine the value of x, or of y when x is 6, and we want to verify our answer. So y is equal to 2 times 6 minus 5. Well, y is equal to 12 minus 5, and y is equal to 7. And that's what we found up here as well. Now we want to write the value of y when x is equal to 6 in the table of values. I already did that. And we want to use the graph to determine the value of x when y is equal to 3. So use the graph to determine the value of x when y is equal to 3. So when y is equal to 3, 1, 2, 3, x is equal to 4. So 4 and 3. 4 and 3. And so I'll do that again. Use the graph to determine the value when x of x when y is equal to 3. So 1, 2, 3, this is where we are. And that's my value of x will correspond to, which was 4. Now, if we complete this statement, this relation is called a linear, so it's a line, because the graph of the relation is a straight line. In class example number 5, we're going to consider the relation described by our equation y equals x squared minus 6. We want to complete the table of values to the right, which shows some of the possible inputs. So when y, this is my equation I'm using, x squared minus 6, and for every x value I have my input listed here. So first of all, inputting 4 for x will result in, so 4 squared is 16 minus 6 is 10. So 4 and 10. Next, I have y is equal to 3 squared minus 6. 3 squared is 9 minus 6 is 3. Now, and then we're going to continue going back up. So -2, or sorry, -5, -2, -3. Or sorry, this is actually plus 3. Now, look what happens here if I don't include brackets. So -1 squared minus 6 will result in -7, but that's actually -5, right? So if you put those brackets in, -1 squared is what I was supposed to be doing. -1 squared minus 6, and you get -5. My ordered pairs, so there they are. Now let's continue. So plot the ordered pairs on the grid provided. So I'm going to start with 4 and 10. That was my first plot. So 4 and 10. And then 3 and 3. I want to use the symmetry of the graph or table to predict the value of y when x is equal to 4. Well, it looks like all these points are reflected in the y-axis, so when x is equal to negative 4 here, we should be back up at 10. So we would say y is equal to 10. And at negative 4, it's going to equal 10, and I'll say negative 4 and positive 10 on my table of values. Now I want to use the equation to determine the value of y when x is equal to negative 4. So y is equal to x squared minus 6. Y is equal to negative 4 squared minus 6. Y is equal to 16 minus 6, which is equal to 10. And we already completed part E, but then we want to connect the points on the grid with a smooth curve. Now this is nonlinear, so why do you think this is called a nonlinear relation? Well, the graph is not a straight line. In fact, this is called a parabola.